right, guys, let's do a few more examples on this little note packet. There's just 4 of them, and it should be pretty quickly. So in example 1, it says, write the coordinates of each point after the 270-degree rotation. Okay, now what you need to do is you need to go back to your foldable, and you need to find what is the rule for a 270-degree rotation. All right, so your rule for 270-degree rotation per your foldable is AB goes to B negative A. Okay, so I'm going to write that here. We have AB goes to B comma negative A. Okay, and on each one of these, this is my A, this is my B. Okay, so now I'm going to find the coordinates. So I'm going to find R prime, I'm going to find S prime, T prime, and U prime. Okay, now AB goes to B negative A. So my B, guys, that's just my second one. So I'm going to go ahead and just do that first. So 1, 1, negative 3, and negative 1. Okay, so the second coordinate of my primes is my opposite of A. So if it's positive, it becomes a negative. If it's negative, it becomes a positive. So negative and then a 3 would just be negative 3. Negative A here would be negative 5. Negative A here would be negative 5. And negative A here would be a negative 2. So now that I have my coordinates, and now that you should have your coordinates, go ahead and plot them. All right, so after you plot these newly points, don't forget to label them R prime, S prime, T prime, U prime. And hopefully your lines are a little straighter than mine. I did the best I could with what I had. But if you do notice, these should be congruent because rotations are rigid motions. And remember, rigid motions mean that they produce congruent figures. All right, guys, example 2 is a little different than anything we've done because here it says write the point coordinates after we go 270 degrees clockwise. Okay, so everything we've done so far and all of our rules are going counterclockwise. Now we're going clockwise. Okay, so this is clockwise, this is counterclockwise. So we can't, we can, and I'll show you how, but we don't have a rule that says 270 degrees clockwise. Okay, so I want to think of this. So if I have a coordinate grid, and I have a point right here, okay, 270 degrees clockwise, here's 90, 180, 270 degrees clockwise would put that point right here. Okay, so I want you to think for a minute. Wouldn't that also be 90 degrees counterclockwise? Okay, so it would be, so I could say 270 degrees clockwise is the same thing as 90 degrees counterclockwise. Now all you have to do is go back to your foldable, and we have a rule for 90 degrees counterclockwise. So go back to your foldable and find a rule for 90 degrees counterclockwise rotation. All right, so the rule for a 90 degrees counterclockwise per our foldable that we've already done is AB goes to negative BA. Okay, so I'm going to write that down. AB goes to negative BA. Okay, now I just need to apply my rules. AB goes to negative BA. So what I want you to do is go ahead and use that rule to find your R prime, your S prime, your T prime, and your U prime on your own, and then we'll go over it. All right, so after you've found, or after you've applied your rules to each of these should be your R prime, S prime, T prime, U prime. Remember on T, your opposite of B, so your opposite of negative 3 becomes a positive 3, which is why we have a positive 3 here. And the same thing here, a negative becomes a positive. Okay, so after you have all these correct, go ahead and plot them. After you plot those new points, you should get something that looks like this. Hopefully yours has little straighter, neater lines. But do note that the pre-image which is this because it came first, and the image, which is this, are congruent figures because these are rigid motions. All right, let's look at example 3. Now, example 3 is a composition. Okay, so remember that compositions are when we put more than one transformations together. So here we're rotating about the origin, 180 degrees, and then we're going to reflect it over the x-axis. Okay, so we're going to have a TUV, which I already have here. Then we're going to have a T prime, a U prime, and a V prime, which will be after the rotation. And then we'll have a T double prime, a U double prime, and a V double prime after the reflection, which will be our final image. All right, the first thing that I want to do is I want to find the rule that tells us how we rotate something 180 degrees about the origin. So go back in your foldable and find the rule that tells you what we do when we rotate something 180 about the origin. All right, so when we rotate something 180 counterclockwise around the origin, this is our rule. AB goes to negative A, negative B. So I'm just going to write that here. AB goes to negative A, negative B. Okay, now I want you to go back and find the rules of what we do when we reflect something over the x-axis. All right, if you go back over your foldables, you should have found that our reflection over the x-axis, the rule is AB goes to A, negative B. Okay, so now it's time to apply these rules. All right, so we first want to start with these, okay? Here's our A, B, A, B, A, B. Okay, now our rule is AB goes to negative A, negative B. So all I'm going to do is make each of these negative. They don't flip orders or anything. So 1, 2 becomes a negative 1, negative 2. My 3, 5 becomes a negative 3, negative 5. And my 6, 3 becomes a negative 6, negative 3. Okay, now I'm going to plot that. So go ahead and plot that. All right, so after you plot it, you should get something that looks like this. Make sure you label T prime, U prime, V prime. All right, now we're going to use the rules of reflection to find the new. Now guys, when I do that, I'm not going back to the original figure. After I get this figure, I'm done with this one, okay? I'm going to use these points and then apply the rules here. Okay, so my AB goes to A, negative B. So my A is here, my B is here. Okay, so the first coordinate, it's just the same as what it is before. Okay, nothing changes. So I start with negative 1. I start with negative 3, and I start with negative 6. Okay, now my B, I'm going to change sign. So if it's negative, it'll become a positive. Positive, it'll become a negative. So my negative 2 becomes a positive 2. My negative 5 becomes a positive 5, and my negative 3 becomes a positive 3. And then go ahead and plot these. All right, so once you're done, this is what you should get. Okay, make sure you label your U double prime, your V double prime, and your T double prime. All right, let's look at rotational symmetry now. So rotational symmetry is just as it sounds. If you rotate this figure so many degrees, will it map onto itself? Okay, so a parallelogram, if I rotate this 90 degrees, this point should be right here. It doesn't work. So 90 degrees is not, it doesn't have 90-degree rotational symmetry. Now, if I rotate this 180 degrees, I do get rotational symmetry. It would look exactly like this if I rotated this whole figure 180 degrees. So I can just write 180 degrees here. And then of course 360 would be all the way around. All right, let's look at this regular octagon here. This is a little more difficult. So if I rotate 90 degrees, this top part here would go right here. So it would have 90-degree rotational symmetry. Now, if I went 180, it would be down here and it'd just be flipped upside down, which it would still map onto itself. And then 270 would be right here. Okay, but this is tricky Because if I go halfway to 90, I would be right here. That's 45 degrees. And this would be rotational symmetry too. Okay, and then if I go halfway between 90 and 180, that's 135. I would also have rotational symmetry. And then halfway between 180 and 270 is 225. That would be rotational symmetry. And then halfway between 270 and 360, that would be 315 degrees. So this would have several rotational symmetries. Okay, 45, 90, 135, 180, 225, 270, and 315. All right, let's do this last one, this trapezoid. Now if I rotate it 90 degrees, this side and this side would be the parallel side, so that's not it. If I rotate it 180 degrees, well, the long side would be down here and the short side would be up here, so it would look like that. So that's not. If I rotated another 90 degrees, so 270, once again my parallel sides would be on the side. So this has no rotational symmetry.